welcome to this course Basic Manufacturing Process Units, Manufacturing Technology second unit first and lecture 9 Material Cutting Operation. Agenda for today present in this video as sensing technologies used in the dynamometer, two component dynamometer design, cutting tool cutting tool materials, carbon tool steel, high speed steel, casting cast cobalt alloy, and cemented carbide. These are topics present in this video. Sensing technologies used in the dynamometer. The described earlier, there are a number of methods by using in by which the cutting force can be for measure mm, for each type of the quantity measure a number of measurement tools for available. They are measuring the deflection and relatively to the simple to the protection, the potential, the potentiometer capacitance of the pickup inductance pickup LVED linear variable differential transformation. The linear variable transfer the measuring the strain more common for low cost of equipment. The strain gauge in full carbide, the half bridge of the there is the quarter bridge and configuration and the measuring the pressure more rich and the expensive. The piezoelectric criticals of the measurement. The two component dynamometer design for the strain gauge system actually measure strain and not forces. There are strain gauge transducer is designed in such a way that the force is measured develop a suitable stress level in the sensing element. The strain gauge the measure of the strain in one or more locations of the sensing element. Strain is measured only locally on several point of the measure point. Many points on the surface of the sensing element to the compensate for the temperature variation. The dynamo structure consists of a rod for suitable dynamometer to provide the necessary rapidly rigidity. A part of the rod in the middle position is the reduced in size of the mechanical flat, which act as the sensing structure. The strain measure both the horizontal and vertical component of the strain gauge of the components. Cutting tools material. Various cutting tools materials have been used in the industry for the different application. Let us look at the important characteristic expanded of the cutting tools material. The second is higher hardness than that of the work for the material begin the machinery, so that it can be uh, percentage of the work material hardness, which is the relative to the hotness, which is the ability to the material to stand is resistant to hardness or elevated temperature in view of the higher temperature existing in the cutting zone. The increasing the emphasis the higher cutting speed to the loss of productivity. Wear resistance, the chief tool and the chief work. The cutting tool material should therefore the high mm, have high absorption resistance to improve the effective of the life of the tools. For that application of the tool materials in the toughness is the tool materials. Even through the tools is hard, it should have the image for this is the materials is the toughness is withstand that the impact load at the material is very low. The friction the tool cutting materials for the property of the low friction, the coefficient of friction between the chip and tool. the co- the the coefficient between the chip and tool should be low, which should be allowed to allow for the lower wear rate and the better chip low, the better mechanical characteristic of than the cutting tool materials for other properties, the better thermal characteristic. Since a lot of heat is generated at the cutting zone, the tool material should have high thermal conductivity to dispense it heat in the shortest time. Otherwise, the tool temperature will become too high and reducing the life of the materials. The this is the tool life of the depend on the material toughness strength of the cutting tool material. All these properties may not be found in a single tool materials. It compensate for the various property of the cutting tool materials of the present. The cutting tool materials and room temperature for the hardness. No, the temperature is hardness of the temperature for 540 degrees Celsius and 760 degrees Celsius, and transfers for the rupture strength is into 10 to the power 3 megapascal. High speed steel. The room temperature is 85 to 87 degrees Celsius for, and the hardness of the temperature is 77 to the 82 degrees Celsius, and very low. The temperature is the very low and 3.8 into 4.5 megapascal into 10 to the power megapascal. The cost of cobalt is the hardness of the room temperature of the 82 to 85, and the temperature of the in 80 75 to 85 degrees Celsius, and this is the other temperature is 70 to the 75 degrees Celsius, and the transfer structure strength 1.8 to 2.8 into 10 k power 3 megapascal. And carbide tools, this is the room temperature for 89 to the 94 or 5. The hardness of the temperature is the 82 to 7 87 87 for the hardness of resistance to the, and the temperature is the 760 degrees Celsius, and the resistance of the tools is the 7 70 to the 82 degrees Celsius for the transfer rupture strength, and the 2.4. The ceramics the room temperature in 1994%, and the hardness of the strength is the 90 is the 94 hardness of the 540 degrees Celsius to the 90 degrees Celsius and the 70 760 degrees Celsius to 87 transfer rupture strength in the, in the zero point 0.5 to the zero point 0.4 into 10 k power 3 megapascal. Diamond, for the diamond is the room temperature is the 7,000 KLPE and the hardness at the hardness of the four, 540 degrees Celsius to the 7,000 for feet. And the 760 degrees Celsius on the diamond is the 7 KNOP. Carbide to steel. These are the The carbide tools, these are the earliest tools material used for the plain carbon steel, which the carbon percentage between the 0.6 to 1.5% and some very small alloy conditions such as the mesons for the silicon, manganese, the manganese, silicon, tungsten, molybdenum, chromium, and vanadium. These are major advantages, which is the range of the cutting tool material, is the novelty of the withstand high temperature. Thus, these are the useful only for very low cutting tool speed, around for 1.15 meter per second, and can be used with low temperature generating operations such as the machining wood and magnesium, brass and the aluminum. They are easy to prepare. They are easy to prepare and the ground for the resultant. They are used for the from the tool making to be the use for low quantity of production. High speed till there are the ability to the significant improve the cutting speed by 3 to 5 times of the 1.5 meter per second. Then the speed prevented to at that the time using the carbon tool steel. This class for the tool material have the significant quantity of tungsten, molybdenum and chromium that the vanadium is also for increase the strength. The complex carbide used for tungsten, molybdenum, chromium, and distributed throughout the metal matrix provide the very good hardness and the absorption of resistance. The main advantage of high speed steel, they are, they are the high hardness of the hot good wear resistance, high temperature, and the reasonable cost. Toughness of the high speed steel is the highest among from the all the cutting tools materials existing in the region that they are quite for extensively used in the term rupture for cutting such that the milling of the materials in that operation. Cutting tool material is also used for the hardness of high HSS files for rapidly bend for the 650 degrees Celsius as the shown in the figure are presented for limited to lower cutting speed of the 0.5 to the 0.75 meter per second. A recent develop is the physical cutting process (PVD). Physical cutting process the physical vapor deposition at a lower temperature, which allows the HSS tool tool that the high temperature of the coated for the hard nitride for the titanium of the aluminum. These are the figure which must be the follower for cutting geometry of the tools that are the hard coating for cutting performance and tool life of the HSS tool for improve the stability for this is the y-axis is presented by the hardness of the axis is presented by the temperature. The variation of the hardness with the temperature of variation of the cutting tools. That is the carbon tool steel. This is the temperature is cutting hardness is the most of the medium and the medium tools. The temperature tools is the medium, and this is the high speed steel. The the hardness is the increase to 85 to the and the temperature is we have the temperature 700 degrees Celsius the and the present in the cobalt is the also present for the hardness of temperature is the below for 80 to 80 and the resistance of the temperature is sustained by the is the above for the approximately for 1000 degrees Celsius and the carbide is the strength is very high strength is very high and the temperature is also strength temperature is the our temperature for the carbide tools is very high. The ceramic material is also for use in the very strong materials. The temperature is also very high. The temperature sustain is very high and the strength is also very high. Thank you so much.